All right, we are ready for lesson 53 of Algebra 1. This is starting on page 215, and we're talking about exponents, and it's called the power rule for exponents. And so over here is kind of what they're talking about. So let me show you an example. If you have a squared times a squared times a squared, you have three of them times by each other. So you could write it like this a squared cubed, okay? Now, what we know about variables that have exponents, when you multiply them together, you're adding the exponents. So 2 plus 2 plus 2 is 6. So this is actually a to the 6th, okay? So over here, when you have a squared raised to the third power, it's not 2 plus 3. What it is it's 2 times 3. You're going to take the exponents times each other. Not adding like we did here. You're multiplying when you raise a power to a power. So if the power is already there and you're raising it up, then you're multiplying. That's what it's called. So 2 times 3 is 6. So this is a to the 6th. Okay? Let me show you if we had something like 5 squared times 5 squared. It'd be something like this, right? So you've got 5 squared and you're taking it times itself twice. So that would be like 5 to the 4th. This is the same thing. If you're adding the exponents, 2 plus 2, you're going to get 4. If you are multiplying the exponents because you're raising a power to a power, 2 times 2 is 4, okay? So that's kind of how this works. Now we're going to use that information to answer questions like this. So let me erase the things that we had over here and look at this problem that we have. Okay, so what you're going to do when you have this is this term, 3 to the 0 power, is going to get raised to the negative 3. This term, y to the negative 2, is going to get raised to the negative 3. Z to the 5th is going to get raised to the negative 3. And then you're going to put that all over x cubed raised to the negative 3 power. So let me kind of show you how that works. So 3 to the 0. So that's basically times negative 3 is what we're doing. So 3 to the 0 raised to the negative 3 power is 3 to the 0 times negative 3. And I'm just writing it this way so you can see it a little bit easier. And then z is to the 5th times negative 3. And then we've got x cubed times negative 3. Okay, are we with me so far? So I took 3 to the 0, raised it to the negative 3 power, y to the negative 2, raised it to the negative 3 power, z to the 5th, raised to the negative 3 power, and x cubed raised to the negative 3 power. This is actually practice question, let's see if I can find it, A on page 216, okay? So that's where we're getting this information. Okay, so let's simplify this. So 0 times negative 3 is 0. And y, when you've got negative 2 times negative 3, you get positive 6. Okay. And then we've got z to the negative 15. This is all over x to the negative 9. Okay. 3 times negative 3 is negative 9. Okay, they want all of the answers, all the variables, all these guys, in the numerator. Okay, so we're going to move this x up to the top. Okay, so before I do that, I'm going to look at this 3 to the 0 power, and I'm going to say, okay, so well, 3 to the 0 power is actually 1. So that's just going to kind of go away. So I've got y to the 6th, z to the negative 15th, and I'm going to move this guy to the numerator because they want the answers in the numerator. Now, when you move it to the numerator, remember it goes from negative to positive or positive to negative, depending on how it starts off. So all of this, when you multiply it through, becomes that all simplified. Y to the 6th, z to the negative 15th, x to the 9th. And this is when the variables are all in the numerator. If they had said, okay, well, actually, I want all positive exponents, then you would have moved that guy, z to the negative 15th, down to the denominator, and you would have gotten something like this. Just like that. Okay, so just make sure that you're reading the instructions on how exactly they want you to write your answer. Okay, so again, this is our answer, y to the 6th, z to the negative 15th, x to the 9th. All right, we're going to do one more example. Okay, here is question B on page 216 that we're going to walk through. We have this fraction raised to the negative 2 power and this fraction raised to the 2 power. And remember, we're going to take each term times that, okay? Even in the denominator, and we're going to do the same thing over here with the positive 2. So these are all going to be times negative 2, exponents times negative 2, exponents times 2 here. All right, so x, 2 times negative 2 is negative 4. Y, when you've got negative 2 times negative 2, it's positive 4. Then we've got 3 to the negative 2, m to the negative 8, and k to the negative 2. Okay, this was 1 times negative 2 is negative 2, 4 times negative 2 is negative 8, and 1 times negative 2 is negative 2. That's what this is, okay? Now, all of this is going to be times by this, okay? So we're going to have some simplification here. Negative 2 times positive 2 is negative 4. 1 times 2 is 2. 3 times 2 is 6, and 1 times 2 is 2. Okay, so here we are so far. Now we have a fraction times a fraction. So we are going to take our numerators times each other and then our denominators times each other, just like you would if you had 1/2 times 2/3. You're taking your numerators times each other and your denominators times each other. And that's how you solve this fraction that's being multiplied. So we're going to do the same thing with what we've got right here. Okay? So we've got an x, and there's no other x's here to really multiply it for, so the x kind of stays there by itself. It's kind of like it's being taken times 1. And then we've got a y to the 4th and a y to the negative 4th. Okay, so these are being added together. So this is 4 plus negative 4 is actually 0, and y to the 0 is 1. So your y kind of just disappears, okay? And you're left with m squared, okay? All right, now we've got a 3 to the negative 2 still, and 3 times 3 is 9, but I don't know that I want to change that quite yet. Let me keep that there for right now. 3 to the negative 2. All right, we've got an m to the negative 8, no m's over here. Then we've got a k to the negative 2 times a k to the 2. Those cancel out because negative 2 plus 2 is 0, and k to the 0 would be 1, so that goes away. And then we've got this x to the 6th left. Okay. Now, they want all of the variables in the numerator, so we've got to move them all up. Let's start with x to the negative 4, m squared. Okay, we're going to move 3 squared up. Remember to change the sign every time you shift it up. So I just moved all of these to the top, and I made them the opposite of this sign, whatever it is. So 3 to the negative 2 becomes a positive 2, m to the negative 8 becomes a positive 8, and x to the 6 becomes a negative 6. Okay, so now you've got these things, but you've got like terms, okay? So you've got an x here and an x here. All right, negative 4 plus negative 6 is negative 10. They're the same sign. You add them together, okay? Here you've got m squared and m to the 8th. Those get added together. They're both positive. And then we've got 3 squared. Well, 3 squared is 9. I'm going to put that out front because I like the numbers out front. So the answer to this big, huge thing up here, when you simplify it down, is actually 9x to the negative 10, m to the 10th power. So that's kind of how you work with these raising powers to powers. Just remember, you've got to multiply them together, okay? Okay, the last thing that we are talking about in this lesson 53 is conversions of volume. Okay, that is when you have cubic something. Remember, volume is something times something times something. For example, if you're finding the volume of a rectangular prism, you take the length times width times the height, okay? So think of that as 3 inches times 4 inches times 5 inches, okay? That's cubic inches. That's inches times inches times inches, which is where you get this cubic inch as your label, okay? That's really important to remember the difference between a centimeter, a square centimeter, and a cubic centimeter, okay? This is what we're talking about. We're talking about something that has 3 dimensions, okay? So we've got 75 cubic inches. This is from practice question C. They're saying we want to convert 75 cubic inches into cubic centimeters, and you are supposed to be using 3 unit multipliers. So remember what I said this is. This is like inches times inches times inches, okay? So we need to get an inch over an inch, over an inch, over an inch, so that they all are going to cross out. So we're going to get inch over inch. It's like 1 divided by 1, or 5 divided by 5, or 20 divided by 20, okay? So these are going to kind of cross out, okay? Think of it as you're trying to put the same thing over the same thing so that when you divide it, it kind of disappears, okay? Because 100 divided by 100 is 1. 1 times anything is the other thing, okay? So we need unit multipliers. So we need something that is going to have centimeters. We also need centimeters up here because we need 3 centimeters times each other to get cubic centimeters. Centimeters times centimeters times centimeters is cubic centimeters. Okay, so we're trying to get rid of our inches. We're trying to get centimeters on the top. So we have a unit multiplier. So 1 inch is 2.54 centimeters. 1 inch is 2.54 centimeters. 1 inch is 2.54 centimeters, right? Okay, so if you took 75 times this 2.54 3 different times, you're going to get your answer, okay? So there's not going to be anything over here. There's not any more labels. You're not going to keep this inches cubed. These inches are all disappearing. So the only label you're going to get left with is centimeters cubed. I'm not quite sure what 75 times all of this is, but once you get it, you write your answer in there, and that'll be centimeters cubed, and that's your answer. So you can use your calculator to multiply all those together and find your answer. Let me show you one more example of this. Okay, the last practice question for this lesson is practice question D, and it says to use 6 unit multipliers to convert 28 cubic meters to cubic inches. Okay, so here's the thing. I don't know how many inches are in a meter. I do know how many inches are in a centimeter, and I know how many centimeters are in a meter. Okay, so you have to figure out, well, what do I know? What do I not know? You could probably run some sort of a calculation to figure out how many inches are in a meter, but if you don't know that, what we're going to do is we're going to figure that out, okay? So the first thing that we need to do is we need to figure out, okay, what can I change meters into that I know converts into inches? So for example, I told you I know how many centimeters are in an inch. So I know that I can change these meters into centimeters and then change those centimeters into inches. I know how to do that. So let's start off by changing this cubic meters to cubic centimeters first. So remember, we want to get rid of the 3 meters times each other, and we want to change that to centimeters. Now remember, we have to change it to cubic centimeters. We can't just change it to centimeters because there's a big difference between a straight line and a dice, okay? So we've got 1 meter is how many centimeters? 100. Okay? We know that if we multiplied this through, at the end of this part of our equation, we would get how many cubic centimeters are 28 cubic meters. Okay, that's what this is converting right here. So now that we have it in cubic centimeters, we need to change it to cubic inches. So these have all crossed out, right? Because this is meter times meter times meter. Now we got to get rid of all of our centimeters. Okay, and we need inches, because we want inches cubed to be on the top and these to all cross out. Okay, we know that 1 inch is 2.54 centimeters. 1 inch is 2.54 centimeters. 1 inch is 2.54 centimeters. So to find the answer to this question, you're going to take 28 times 100 times 100 times 100 divided by 2.54 divided by 2.54 divided by 2.54. Okay. And you're going to get, let's see, 1,708,664 and 84 hundredths inches cubed. It's a big number. But when you multiply this through in your calculator, that's what you're going to get. Now, because this is on the denominator, that's why you're doing the division part, okay? So don't take 28 times 100 times 100 times 100 times 2.54, okay? That's not how this is going to work. If you're multiplying all of this together, remember, you're multiplying numerators together, 28 times 100 times 100 times 100 times 1 times 1 times 1, and then you're multiplying denominators together. Okay, so do not take this and multiply them all together. Remember, it's this divided by this. Okay, this is not up here being times. That's not how that works. Okay.